Welcome future mathematicians, to an MLG Pro guide to rainbows. This diagram isn't very dank. However, it does show that sunlight is broken into its components when it moves through a raindrop, forming a rainbow. But first, let me explain some basic properties of light for all the filthy plebeians living in their mother's basement. Light can be reflected off of a surface, such as a mirror, with the angle of incidence equaling the angle of reflection. But if light travels through a material like glass or water, it will refract towards the center of said material. When sunlight enters a raindrop, most of the light reflects back towards space. The light that enters the drop refracts, before reflecting off of the rear end of the drop towards the front, where it refracts and disperses once more. This is why a rainbow can only be seen when the sun is behind you. Always remember, children, seeing a rainbow indicates an imminent sea bear attack. Draw your sea bear protection circles the moment you see one. But why doesn't a rainbow appear all over the sky when it rains? What stops every raindrop from creating a beautiful rainbow? Calculus. Calculus has foiled our fun once again. Calculus should go lock itself in a washing machine. Unfortunately, rainbows are locked in place by the great angle of rainbows, which is also the answer to life, the universe, and everything. 42 is the answer, 42 is the answer to life. 42 is the answer, 42 is all you need. As you can see, the angle of incidence is alpha and the angle of refraction is beta, which also turns out to be the angle of reflection. The total deviation of the light is written as the function d of alpha. To find d of alpha, we must add up all of the angles bending the light towards its exit. Alpha minus beta happens wherever the light refracts, and when the light reflects, the inside angle is 180 minus 2 beta. This formula simplifies down to 2 alpha minus 4 beta plus 180. An important piece of the upcoming calculus montage is Snell's law. Snell's law relates the angle of refraction to the angle of incidence by comparing the index of refraction of the two mediums. Air is approximately 1, red light in water is 1.33, and violet light in water is 1.35. Normally the index of refraction of water is 4/3. We will now use advanced calculus to prove that rainbows appear between 40 and 42 degrees. Wait. What is that? Could it be a bird? Perhaps a plane? No. It can't be. It's Shrek over the rainbow.
Somebody once told me the world is gonna roll me. I ain't the sharpest tool in the shed. She was looking kind of dumb with her finger and her thumb in the shape of an L on her forehead. Well, the years start coming and they don't stop coming. Fed to the rules and I hit the ground running. Didn't make sense not to live for fun. Your brain gets smart but your head gets dumb. You'll never know if you don't go. You'll never shine if you don't glow. Hey now, you're an all-star. Get your game on, go play. Hey now, you're a rock star. Get the show on, get paid. Only shooting stars break the mold. It's a cool place, and they say it gets colder. You're bundled up now, wait till you get older. But the media man beg to differ, judging by the hole in the satellite picture. The ice we skate is getting pretty thin. The water's getting warm, so you might as well swim. The world's on fire, how about yours? That's the way I like it, and I'll never get bored. So much to do, so much to see, so what's wrong with taking the back streets? You'll never know if you don't go. You'll never shine if you don't glow. So much to do, so much to see, 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 so much to do. You'll never know if you don't go. You'll never shine if you don't go. Hey now, you're an all-star. Get your game on, go play. Hey now, you're a rock star. Get the show on, get paid. Only shooting stars break the mold.
Praise Shrek. Ahem. Excuse me. Now that we have that out of the way, I should probably explain those last few steps. Since d of alpha is how much the light bends as it moves through a raindrop, the change relative to the receiving eye and the initial ray is 180 minus d of alpha. So red light comes out at 42 degrees, and violet light comes out at 40 degrees. And all of the other colors of the rainbow, minus the cheating color indigo, appear between 40 and 42 degrees. And now a brief intermission. This diagram is also lying to you, as pink isn't a real color. However, it does reveal an interesting property of rainbows. They are made up of millions of tiny droplets, each sending a different color of light towards your eye depending on their location. Oh indigo, you filthy try-hard, the real scientists who ditched Pluto proved that you don't belong in the rainbow years ago. This picture does show that the wavelengths of light affect how much the refractors they change mediums. Hence the varying n values. Rainbows are circular because all of the droplets between 40 and 42 degrees are directing light towards your eye, forming a cone with your eye as the apex. This also means that each of your eyes see a slightly different rainbow, and nobody can see the exact same rainbow as you. Every rainbow is truly unique. They are even more unique than socially awkward penguin. Since red light is the lowest visible color coming out of raindrops, only the higher raindrops direct red light at your eye. This is why red is always on top of the primary rainbow. Some of you may be wondering, if there is a primary rainbow, is there also a secondary rainbow? Perhaps even a tertiary one? What if we took the derivative of rainbow? Let me stop you right there. I'm not being paid enough to look into Photoshop triple rainbows, much less the insanity of another derivative. However, double rainbows do exist. They are created when light enters a raindrop from the bottom, and reflects twice inside the drop before coming out at a much higher angle. An interesting way to tell if a picture of a double rainbow is fake is that the secondary rainbow is actually inverted, with red at the bottom, and violet at the top. Most uncultured internet weeaboos just copy the first rainbow and make it bigger to go around the primary rainbow. Thank you for watching. I hope you only lost a few brain cells viewing my presentation. Make sure to stay until after the credits for a special surprise.
Take it easy! What the scallop? I'm a goofy goober! You're a goofy goober! We're all goofy goobers! Goofy, goofy, goober, goober! Put your toys away! Well, all I gotta say when you tell me not to play, I say no way! No way, no freaking way! I'm a kid, you say. When you say I'm a kid, I say it again! And then I say thanks! Thank you very much! So if you're thinking that you'd like to be like me, go ahead, try. The kid inside will set you free. I'm a baby, Lizzie, I'm a baby, Lizzie, I'm a goofy goober! Oh, what's happening? Huh? His dance moves are impressive, but I'm in control. See him!
Sam, southwest rooftop.
Who the hell's the other guy?
About to find out.